Hello ladies and ladies, welcome back to another railroad development stream. I don't know why my camera's not on. I have been trying to figure it out for the last 5 minutes and I can't get it to turn on. So I genuinely don't know what to do. It literally worked like an hour ago, but it has just stopped working, I guess. So this might be a new camera stream, which I haven't done in a very long time. Let me just try something real quick. There's one thing I haven't tried. Okay, let's see. Has my method fixed it? Hey, there it is. Okay, I just had to unplug it and plug it back in, apparently. So yeah, we're back with another railroad development stream. We're going to be continuing working on the SST. Now, I will say, going forwards, I don't plan to continue streaming the SST. Just because I don't think it's the most interesting thing, and it's kind of going to be this like ongoing thing that's going to kind of go for a long time, because basically we're effectively building an entire Java compiler, if you think, not entirely but close enough. So it's going to go for a while. It's not going to be a quick thing. So I just want to state I don't plan to continue streaming this for ages, and we're going to start doing some other stuff soon. Before I do that, let me quickly announce on Discord. And okay, done. That is now announced on the Discord. So okay, what we're going to do today is we're going to work on basically unreachable code. So for example, I will give you guys an example of what we're trying to do. For example, here I have return false. If I try and type sout hi, IntelliJ will give us an error saying this is unreachable code or an unreachable statement. So that's basically what we're trying to implement. And I've kind of already put a basic class together, but we're not even close yet. So this is going to be one of the more complex inspections. So I'll briefly go through what we have, although it's hard to explain. So effectively, we're looking for all of the block nodes. So for example, like just these, basically any of these, we're going to go through there. We're going to grab all of the children, so basically all of the blocks. We're going to go through all of the blocks. I'm going to call this analyze block method. This is going to get all of the statements inside that block, because we don't care about things like semicolons, we don't care about things like comments, we don't care about things like white space. So we just want all of the statements, and then we try and figure out, is that statement reachable? So we go through all of the statements. We check if the block is reachable, not necessarily the state. Well, no, we do check if the statement is reachable technically. So for example, first of all, if it's not reachable, then we just report that statement. If it is, then we check if it's reachable. So for example, and also I think this should have a break here, maybe. Not sure. Regardless, we check if the current statement is basically a terminal statement. So return statements, throw statements, break statements, continue statements, you can't write things after that. So at that point, reachable is false. So then the next statement would be unreachable, and so it reports that statement. That's basically how this works. And here we just check if it's a block rather than one of these. So here we can actually just continue. So if the statement is a block, then we need to go into that block and basically repeat the same process. It's not going to work quite like this, though. This is more of like a temporary thing. Because we need to do a lot more than that. So just trying to see. So I mean, for example, right now we are just grabbing all of the statements, but that isn't necessarily what we want to do. So one way to start would be to just do this, because there's no need to make a variable for that. But let me see. Okay. So I've created this method here, so it completes normally. And what this should effectively do is say whether or not the statement is one that would allow it to finish the block, basically. So return, throw, break, continue. These don't just let you move on after these statements have ran. And a block statement would depend on basically what the last reachable statement in that block says. And then normal statements, we just return true because those are going to be fine. Is effectively how we do that. Now, this is not going to work. So, like, this is going to be air. If you've got something like an if statement, that's not necessarily what we actually want here. So I think let's do a little bit of a rewrite. I think let's not start, because currently we're starting by just grabbing all the blocks, which works, but it's not really what we want. We really want to be able to analyze the specific executable blocks, because not all blocks are executable. So let's design a method, something like private static void analyze. I'm trying to think what we I think we use these in most of Railroad. So analyze executable bodies. I mean, Copilot says body, but really bodies, because we're not just grabbing a single body doing this. So we can take in here a Java rule context, which is the context, and we can also take in the Java inspection rule reporter, which is the reporter, and then we also want to take in the kind that we actually want to do, so body kind, as Copilot suggests. And then what we can do is we can do context.nodes of kind. We can pass in the body kind, and then we can just do a for loop, and we can call this like owner, maybe. And then we just want to grab the block. So we can grab syntax node block is equal to context dot direct child owner Java block. That'll grab us the block. If the block is not null, then we can call our analyze block. Now that does, I believe, need to also pass in the context, which it currently doesn't. So let's pass that in. There we go. And then we can just kind of nuke this method and we can rewrite it a little bit. So we want to do this for specific, yeah, basically the ones that it has just suggested here. So I'm going to do context, reporter, and are these all correct? So methods, constructors, instance, static. We also want lambda expressions as well. Yeah, I think so. So let's put these a little bit separate because they kind of are separate. But apart from that, those are fine. So then analyze block. We can start off the same. But I think going kind of from there, we should look at getting the executable children, not just statements. So executable children. If it's not reachable, we report, and then I think this should just become reachable is equal completes normally, and then just return return reachable. And we can make this a boolean as well. So let's edit this so we can kind of start the same. But there's no reason like why we can't use a switch statement here. I don't know why I didn't do that originally, but we can easily just switch on the kind. And then just do case. And we have return, throw, break, continue. It's going to be false. And then case block. So that's Java block. Will be analyze block. So this needs to take in the context and reporter as well, so that we can then call analyze block, and then default will just say true. Okay, so that just needs to pass all of those in. Now let's create our direct executable children method. So executable children, which will take in a syntax node parent. And let's just go ahead, create our temporary list. So like children is equal to a new array list. And then if we do parent.child or parent.children.for, we just want to get the tokens. So if child is instance of a syntax token, then continue. And then add it to the result otherwise, and then just return the children. And that effectively does what we want. Hello bot2560z, that is a very bot name, I will say. Welcome to the stream. And then okay, what are we missing? Because I feel like we're missing something. Oh, we need to handle if statements, because if statements are going to work differently, right? So if we do case Java if statement, let's create a method for that. I think analyze if statement, And yeah, just pass in our usual parameters. Does that already exist? That's interesting. Didn't think it did, but okay. It exists in another class, apparently. So, yeah, here we want some kind of private static boolean, analyze if statement, and no, we don't want to do all of that. So, first of all, let's just get the children, because that's going to be exactly the same. So children, and then we can do syntax node. We can take the then branch, and we can take the else branch. These both need to be null, of course. How difficult is writing an IDE compared to other projects? It is not easy. I can say that for sure. I guess it depends what you mean by other projects. It depends what your other projects are, right? It's certainly not a beginner project, I can say that. But yeah, I mean, other than that, I mean, it's not easy. It's going to take a really long time to get this done. But that's I knew that going into it, so. Check that it ends with underscore statement. Okay, then we can say if the then branch is null. Is this right? Yeah. So then the then branch is just the child, right? And else, the else branch is the child, and then if in that case we then break because we have the else branch. Okay, yeah. And then if the then branch is null, then we can return true, right? Because that's fine. But then we want to know if the then branch completes normally. So effectively, we can just call completes normally on the then branch. Yes. So boolean then completes, and then if else branch is equal null, return true, and then boolean else completes. And then we can just return that then completes or the else completes, in which case then that returns. Yeah, that should be fine. Like, what other projects have you written or made? I have worked on a lot of different things. I made my own programming language for university. Wasn't really a full project per se. Also, I can turn my light back on now. We go. This is. Do I say this is harder than that? I don't know, because I'm basically doing that right now. So yes, I would say this is harder than that. I have worked on many Minecraft mods, and this is obviously exponentially harder than that. Like, it's not even really comparable. Other than that, I mean, I've worked on my Discord bot, but once again, this is like not even comparable to that. I don't know, it's not really comparable to like any normal projects, because this is a massive project, right? I mean, if I run SCC, we have so let's see, code, we have 77,946 lines of code. Not actually that bad yet. Yeah, I mean, it estimates that this would take 21.64 months. So that's, I mean, that's probably about correct, funnily enough. Estimated cost, $3.2 million. I wish, well, I wish I had that money, of course. I mean, I'm glad it doesn't cost me that much to develop this, because obviously I don't have that kind of money. But yeah, I mean, it's a big project. Just this part alone. Honestly, this is the biggest part, though. Writing it like a full-on SST is by far the hardest part. And bear in mind, I have to do this for other languages later down the line as well. If you want to support something like Kotlin, we'll have to do this for Kotlin. Though, I'm thinking when it comes to something like Kotlin, I suspect Kotlin has just a better compiler API generally, so we might be able to kind of wrap that in the SST rather than write it from scratch. I guess there isn't really a scale of difficulty. Yeah, I mean, it's just so different to everything else. And I would debate that it is like, I mean, it's one of the most complex things you can do, technically, kind of. So... I mean, we need to... So, what do we actually need to handle next? What are we done with? Well, so, I don't know why I closed it. I'm losing my marbles. So, we're doing blocks. We've done ifs. We really need to handle loops in here. And then we need to consider switch statements as well. I mean, they're going to be pretty similar. So we really want to do loop switch, and then after that we want to do like try catches, right? Now, only thing is, we probably want to write some tests. So I might just quickly get ChatGPT to do that. 1 second, I need to just message someone. Okay, that's fine. Okay. Okay, I've got ChatGPT to go ahead and start writing the tests. So it should be doing that now. Yeah. Okay, we do need to make sure... And you know, we can actually just test it like in the IDE, right? Whilst it's doing that. Yeah, let's do that. Okay, it says it's wrote the test. We'll check those in a second. Okay, actually wait a second, because it's gonna start running the tests. So we'll give it a second to run the test first, and then once it's run the test, then we'll run the IDE and we'll check. Here, I've just set it off on that task. Oh, has the stream froze? Shall I stream? Oh, it's back. Okay. Yeah, I'll just give it a second to run the tests. It's probably, I mean, it's probably faster to run it locally. The thing of using codecs is it has to rerun through WSL, so it's like so much slower. It's actually tragically slower, but it will just run them. It's just gonna take a while. Okay, because it wrote these in court inspection rules tests, so we just find court inspection rules test, we can see, yeah, so that's the inspection itself, and then we find those, so they're probably going to be at the bottom. Oh no, they're here. I don't know why it's put them here. So what it's trying, so it's trying return here, and then it's trying to do an assignment. Okay, it's doing a throw, and it's trying to do assignment. Then it's doing an if statement. Okay, and then it's trying to do another if statement, and then that's all it's done. I mean, those should be fine. What's there? Yeah, I don't know why that's there. That can just be a method reference. Is it not done yet? Oh, it's compiling. Yeah, first time it compiles, it takes a long time. So once it's compiled, we can actually run the IDE anyways, because at that point it's not gonna like cause an IO error or anything. Just whilst it's compiling, it would. So we'll just wait for it to compile. The good old waiting for LLM. Oh dear. I'm running out of water. Should have filled up my water before the stream. Okay, did it just give up? I think it just gave up. Okay, we can run it ourselves. Let's just go terminal. It'll go much faster if we run it ourselves. Oh, that didn't work. Oh, escape behavior. Cringe. Okay, yeah, that hasn't worked because, right. Only problem is why it, for some reason it thinks that's too long. What if I do, how long does it need to be? Oh, okay. Because we can't paste that in there. And oh, if we do it like that, that works, I suppose. So if I do like that, tests, run that, should see that the tests pass. Don't see why they wouldn't, but we'll check, of course. And yeah, as I said, I don't want to keep doing SST on stream, so I actually don't know what we're gonna do if we're not working on the SST, I will say. Let me quickly check the GitHub project so that I can try and see if there's anything on there. The problem really is that a lot of things are dependent on the SST. Does that work, by the way? It failed. Interesting. So this is 726. Why can I not jump to that, by the way? So that's towards the bottom. So 726, that's these one. Core exception rule emits invalid exception type diagnostic and try resource close diagnostics. I don't remember what this test is for. I'm not sure. I'm just going to give it that and see what it says. Do you have the GUI? Well, yes, we've done all the GUI. But really, we're stuck right now. I think we are reliant on the SST. I'm trying to find the friggin' projects page. Oh, GitHub's moved it. Okay. I think. Maybe I'm going crazy. So this is basically everything we can work on right now. So I could work on Neoforge and Forge project onboarding. The only problem is that kind of, not entirely, but it kind of relies on this, which is having a project templating system. And the problem is that relies on the SST. I don't know if we can make it not rely on the SST. Not really, I don't think. The other thing we could do is a project process manager, which would handle all the processes. That's a really good idea, and we do need to do this. Once again, I just don't know if that's a good stream thing, because it's not very interesting. It would be very boring, and honestly quite simple, I think. This relies on SST. I don't know why this isn't blocked by... So that's blocking that, but this needs to be... One second. Let's make this blocked by SST. It's not called SST. It's Semantic syntax tree. That's it. There you go. Yeah, I mean that's blocked by that anyways, but so I mean we can change this one to say add or change blocked by, and we can say that's not blocked by SST because now this is blocked by SST anyways, so that's fine. Icon packs is something we could do. That would be very easy though. That would probably be an hour or two's work. But really everything here, as you can see, relies on the SST. This, I mean, this doesn't. I mean, we could do that. Auto update could do that, but that would require writing an installer and stuff, and I don't know I want to get to that yet. One second, what has this said? Are not from the unreachable, they're from older failures in the what they mean. Right. I'm just going to tell it to fix them. I can't be asked to go back and fix those ones. Can you fix them? Lovely. Okay. You want me to run the... Yeah, we can run it. Okay, sure. Let's give it a run. I mean, we can test our unreachable code as well whilst we're at it, because it did say those tests passed anyways, so... Let me move codecs over here so I can watch it. Oh, it's complaining about an IO error. Hopefully it learns it can just use a temp Gradle dir, but it, you know. I just realized I didn't have it on the screen, but okay, so let's close these because we don't want these. Oh, the other thing we can do is we can have a switch between like Git mode and normal mode. That is something I need to do as well, but that's going to take a minute, so I'm kind of hesitant to do that. So let's do a new file. Let's just call it h.java. Okay, let's do public class H. Hello, Frosty Flipper. Welcome to the stream. And let's do like void run that. 2, 3, 4. Let's just do return. And then let's do int I is equals 0. And that should tell us that that's an unreachable statement. Nice. Let's try again. So void run. So that's just going to say it's a duplicate, right? Yeah, so we can do run 1 or something. And then let's do like if true, because it won't evaluate that yet. So that's fine. And then we'll just say return int I is equal 0. What does that do? Okay, so it doesn't care about that. Hello, Cyan. I'm just gonna say Cyan because I Cyan Opsitax. Sure, I'm just gonna call you Cyan. Welcome to the stream. Interesting. Codex is actually saying those tests do pass. But they didn't pass, so I'm a little bit confused. Let's try run it again and see what happens. But it says they should pass. So let's see why they didn't pass. Or let's see if they don't pass again. Maybe I just messed something up, or I don't know. Yeah, it's saying they're not passing. Okay, I'm just gonna tell it. I'm telling it they're not passing. See what it says. Bro, just fix it, bro. I literally asked it to fix it, and it's like, okay, blah, 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 blah. Just fix it. It's not that hard. I'm literally going to say just fix it. You guys can't see, actually. So, what tests are failing? Let's have a look at this. Let's see if we can figure it out whilst it's trying to figure it out. So core exception rule. So exception rule omits invalid exception type diagnostics and try resource closed diagnostics. Crazy name. Exception rule omits unreachable catch diagnostic. Right, unhandled checked exception. Right, so where are these coming from? What inspections are they coming from? So we have a checked exception, right? I actually thought that was one that we had. But they are all to do with exceptions, so do we have just exception inspection? That's probably the one. So they're coming from here. Let's just see what it's doing now. You can run the test. Okay. Now we have to wait ages, probably. Yeah, as I was saying, the other one we could work on, and I've been kind of delaying this a little bit, is the index manager. It wouldn't be hard. The thing with the index manager is it's just like not that important right now. And I kind of want to do things that are important, but realistically the only important thing on here is the SST, because that's what's stopping everything else. What? How did it pass? What? Wait, how did the test pass? It doesn't pass for me. What? Let me try this again. No, it's not working. What if I do dash a scan? Yeah, it's gonna take a while. Oh no, it didn't take as long as I thought it would. Oh, it's not running the right Java version. I see. Wait, what Java version is it using then? Project structure. We should be using 20, so 21 there. We need to check Gradle though. Oh, I know what the problem is, because my Java home is no longer 21. Let's just say no, don't care. Yeah, my Java home is 20. No, my Java home is 25. I mean, because I just did the 26.1 modding tutorials, so I set my Java home to 25. So now it's trying to run this with Java 25. You can pass. Ooh, do I remember? Dash D. Is it just dash D java.home? No, it's not. It's. Oh, I don't know. Let me do a Google real quick. Ah, found it. So it is dash D org.gradle.java.home is equal, and then I need to set this to wait, is that right? Yeah, that's right, isn't it? I think so. So I need to set this to my Java home. Let me quickly go ahead and find my Java home. I think it's on my D drive, JDKs. No, I don't have a 21 in there. Struggling to find. Aha, found it. Okay. Is that gonna work? Doesn't like that. Interesting. Is that not right? I mean, we can just set it in like the Gradle.properties, but that's obviously not ideal. I change them to forward slashes maybe. We could also try moving the argument further down, actually. So, like, currently it's there, but we can move it. What? Why did I just do that? Oh no, wait, that's fine. Never mind. I thought it was removing. It was removing further down. I think if I put it at the end. Why is that not working then? What am I doing wrong, chat? No. Say no again. The org.gradle.java.home, org.gradle.java.home. Oh, it might need to be in double quotes, not single quote. Nope. Wait, is the put.gradle asking for Java 25? No, it is asking for 21. Suspicious. Okay, well, we can try just export the environment variable, I guess. So we can do export. How do you do it again? Export. It might actually be lowercase. Export. Java home equals, and then paste it in the path. No, it is uppercase, right? I think it is uppercase. Can I do yeah. No? I don't know how you do this. Either way, it says it passes. I'm gonna trust it because I mean, I can see it has actually worked. So it's obviously just not working for me for whatever reason. And I can't bother to change my Java home. It's just not worth doing. So we'll leave it as is. Right. So I mean, what's right? So what do I need to do now? Okay, so finish that. We need to rewrite analyze block. Completes normally needs to handle return, throw, break, continue, nested blocks, nested ifs. Am I crazy or have I not done that? Yes, I have done that. Okay. Okay, yes, I have done that. Lovely. So now what's it telling me to do? I'm pretty sure it's loops and switch. But so direct executable children is too broad. It returns every non-token child. In analyze if statement, this means if you're scanning conditional expressions and other structural Okay, so next is just to edit complete normally, right? And just add the loops in there. So we want to come in here and we want to do like a case. Let's start with, I guess, while loops, because they're the most fundamental loops. And we'll go from there. Yes, I mean, as it says, we want to analyze while statement. I guess we might as well just put all the kind of boilerplate in there. So do while, and then we've got for and enhance for. So for and enhanced for, which will analyze the for statements. Okay, so it also says we can simplify our if statement code. Like significantly. It just says we can do that. But we need direct statement for children. Does it say what that is? Oh, I see. It's basically just taken what we had and it's put it into a method. So this. Java underscore block equals kind. Yeah, this is basically what we had, right? So it's just simplified the code, basically. Yeah, so if that's empty, then it does that. If that's one, then it does that. So we get the else branch, and then we do basically the exact same as what we had before, right? Okay. Okay, so let's do while statement then. No, we wanna create the method. How do I? Hello? Can I just create the method, please? I want you to import it, but I don't want to import it. I want to create it. Fine. Private static. Okay, so what's it done here? Direct statement children. No, so it's saying we're gonna need a way to get the first direct statement and the last direct statement, which has actually written those methods for us. So we might as well take them whilst they're there. Yeah, that would be a nice simplification, IntelliJ. Thank you. Okay, so what it's saying we do. So we take the first statement, so we take the syntax node body. If it's null, return true. Correct. So then it contains a reachable break. Yeah, but we just want to return completes normally, right? That's basically it. And then analyze do statement, basically the exact same. And then analyze for statement, the same. I think that's it. So let me just look at some code we have. Okay. What's it saying? It's saying we just call completes normally. That doesn't make any sense. Or am I crazy? So it says like here, for example, we should just call completes normally and return true. I don't really get what the point of that is though. Like surely that just always just returns true, right? Okay. I've told it to add the tests, so we're gonna add the tests. We'll see what happens. Okay. Make sure Railroad isn't running. It's not. And wait for the test to run. Check that it is actually running them. Since we can't run the tests anymore, or at least I can't on my PC because my Java home is the wrong version. I mean, technically, actually, I could just run it through, I could run it through here. I could run verification test. And that, I think, would work. It's going to run more tests than we need it to run, but I think that will work. What is this? Is that fine? Yeah, I think that's fine. Okay, what are these? You will try to index 0. What is this? What is this? Okay, I think this is meant to reference a specific Java file. Rather than just be, this is not right. Where is this running in? That's the Java Semantic and the Analyzer test. Interesting. Noted. Noted. I have to remember that. Okay, it's still running the tests. And then once it's done that, let's try and find something to do other than the SST for the streams. I think that's a good step forwards. Okay, let me just have a look through projects. There's got to be something. And we could try and fix the Neo4j Forge onboarding. That is probably the most important thing on here that we need to do. Either that or we could I'm wondering. So because all we're doing right now is semantic analysis, right? So effectively the SST is done other than the implementation for Java, right? Specifically semantic analysis. So what we could do is we could We could start working on the actual like API for the SST, so that we can then actually proceed with the things that are currently blocked by SST. Because really all they require is the API. They don't require it to actually work. It just needs to have the API in place. And you know, temporarily we could get it to return some like mock results or whatever we need. So we could do that. Let me just open what I have for SST. So the only problem is the SST doesn't have a project model. So currently the SST only handles single files. It can't handle like relationships between files. And that would be important for everything. Things are going to require that. So wonder if we can get it to yeah, I think to be able to do that we have to work a little more on the actual indexer. So quite a long time ago actually I wrote an indexer, which I think is what we're actually still using, funnily enough. It's basically all there. Now, obviously this just scans basically the standard library. So Java 8 or below, it just reads the rt.jar. Newer version, it scans the JMod. Now, we could feasibly extend this. You see, yeah, you see here the semantic analysis basically just uses that. But obviously that won't use all of the files in the project. So the next thing we have to look at is indexing the project, and then also we need to index all of the libraries in the project as well. Basically, by the way, this is what IntelliJ does. When you load a project up, you see in the bottom right, it will say like scanning indexes or something. That's effectively what we need to do. Now, it's not that easy, I will say. Okay, I'm just gonna get... Let's get... Oh, hello. Someone's messaging me. Okay, that's fine. And put my phone on silent, shall we? Okay, there we go. So I'm just going to get ChatGPT, or Codex, I should say, to finish the for loops, get this in a state where it's okay, for unreachable code, and then we will commit, and then we'll begin working on indexes. Okay, it's running the tests again. No one's surprised, of course. So I don't know if we want to necessarily. So how does this work? It builds a trie or something, right? Or a tree, or what? I don't even know how you say it. A TRIE. Does it not? Oh, I thought it did. Oh, I see. It just returns it out into the list of stubs. Is that right? I see. Okay. So it actually doesn't do that. But does this use that? No, it doesn't. Okay. I see. I think it did originally. I think when I rewrote the parser and semantic analysis, or when Codex did that, I think it's rewrote this slightly. Yeah. It has, I think. Which makes sense. That does make sense. Yeah, it's created a class stub visitor, which basically converts. Okay, yeah. I see. That makes sense. That's smart. Wait, no, I wrote this. It didn't write this. I wrote that. I think. Wait, I actually don't know now. Okay. Okay, it insists that we have to do switches first, so it's going to do switch statements first. It's going to be exactly the same, I think, though. They're all pretty similar, right? And then what we'll do, we'll commit, and we'll probably go into a new branch. We'll branch maybe off of SST, I think is the best way to do that. And yeah, we'll have to have some kind of like project model or something. Okay, let's. Okay, so this is done with switch statements, yeah, and as I suspected, it's basically exactly the same. We can quickly just have a quick peek at what it's done, but switch statements, yeah, it just checks for switch rules and then goes through the rules and checks for labels. That's basically it. Just wrote some tests. Let's just let the tests run, and then that's not unreachable done, but like that's done enough that like it's usable, is what I would say. So that's good enough for me. Oh, what did I just do? What did I just do? I don't even know. Okay, that's fine. Okay. So we also at some point need to define like a quote-unquote language class so that we can do things like per language. So for example, being able to say like document.getLanguage or something, because if I go into the document class, I don't think that's something I implemented. I think we have, yeah, we have a language ID, but that just like gets the end of the name. It doesn't actually get us like a language class. because we need to be able to get like the parser, the all of those shenanigans. Let me just see what Codex says in regards to. Okay, it says we need to try and finally and make switch less conservative, but good enough for now. So I'm gonna go commit that. Need to wait a second for it to. Okay, commit. Push. Okay, and now I'm going to create a new branch based on SST, and we're just going to call this like project model. Okay. Okay, I've set Codex on giving us an action plan for implementing the project model. So as you can see, we're now on the project model branch. So yeah, we're going to start by kind of defining, I think, basically an API. So in here we already do have like a semantic API, so that's fine. And the parser also by the AST exposes basically all of this as an API. We have the syntax API as well. The Lexa, don't think. I mean, the Lexa basically is fine on its own. Like everything here it exposes is not like internal really. So I mean, those are going to be fine. Hello, Wide. Welcome to the stream. Things are going slowly. We're trying to find something different to work on, other than constantly working on the SST. Even though we are now going to continue working on the SST, we're hopefully just going to like finish the SST. Well, not finish the SST, but finish the API for the SST, so that we can actually start using the SST. Okay. Okay, so what it has said. Okay, so it says we should start by creating a project semantic index, which basically stores a path to a snapshot of a file. Okay. So we want to come in here. Let's create a new package. Let's call this I don't know, because it's like it's just like project. Yeah. No, what? No, we want it in the SST package. We want it in here, project. And then we can define some kind of like project semantic index. I put that as an interface. Do I want this to be an interface though, or a class? Probably an interface, because then we can have like an in-memory one and we can have a file one. And like the file one could be abstract, and that could have like a database one or like some custom index file or something. I don't actually know how IntelliJ like stores indexes. I don't know how they do that. But I mean, that's basically what we want to do, right? So project semantic index. Wait, let me just see what codex said. Oh, I see. It's done it a little bit different than how I was planning to do it. Or it's saying I should do it differently than how I was planning to do it. Okay, okay. So the index itself... Right, okay. This makes more sense, actually. So in that case, we'll make this a final class. And then in here, we'll basically store the files, first of all. So this is the index, I guess. So it'll be a map of a path to a like source file index, which will be the files by path, and then we'll define a map of string to a list of source file index, and this will be the files by the packages. And then we can have a private final map of string to a list of symbol descriptors, which can be the symbols by symbol name. And then we can basically duplicate this for symbols by qualified names. And then it says we should also have a... No, we don't want a symbols by package. That just doesn't make any sense. We want like a symbols by... Basically going to be the same, but it's not going to be... we want members by... It says members by owner qualified name. What does that mean? Members by owner. Right. Okay. So you would have... Right. So you would have like an... Okay, that makes sense. So members by owner qualified name. So what that would mean is that this string would be, for example, the name of the source file index, or well, the name of the class, basically, I guess, right? Or well, the name of the owner, because the owner has members. It doesn't necessarily need to be a class. It could be an interface. It could be a method, even, I guess. Wait, no, would it be a method? No, not really. But like classes, interfaces, enums, all of those. So import map, import list. We'll create a private project semantic index, and we'll have a map of a path to a source file index, and get rid of those. And then basically we just build the rest. So files by package name is going to be equal to... So it says we should do oh, I see. Okay. to do copy and normalize, and then this will be build files by package name, or build files by package, I guess is fine. But that needs to be this files by path, so that it uses this one, which we will have then copied and normalized, rather than the one that hasn't been normalized and hasn't been copied. And then build symbols by simple name, basically the same. Symbols by qualified name, build members by owner qualified name. But these don't need to have the keys, right? None of these ones even. They need to have the keys, so those will be fine like that. Okay, so let's create a public static project semantic index, which will be our empty implementation. And then we can have a builder, so public static builder. And we're going to want a way to get the files, so public map of path. We'll just call this files rather than overcomplicating things. We want a way to know if we have a file, contains file, and then we can do public optional get file. Let's just make sure we normalize the path. Yeah, we can use file utils. That's fine. Then we want to implement our first one. So build. Oh no, do we? No. Yeah, let's implement our first one. So let's do. Let me just bring this over so I can see the stub. Oh god, I can't friggin' grab. Okay, that works. Not quite what I wanted to do, but that works. Oh my god, this is not working whatsoever. There you go, I got it. Okay. Okay, so we're gonna want. Let's first of all add a way to copy the map, I think, because otherwise it's gonna be jank. So we'll have a private static map of path to a source file index, which we copy file map. We'll take in the original. We'll just put that the source. Well, no, I think original is fine actually. I prefer original. So we'll do original, and we'll set that to objects requiring on null, and then we'll do path to a source file index. Copy is equal to a new linked hash map. We can do original.size as well. Then for each entry, then we can do copy.put. File users to normalize path. And then also we want to simplify the value as well. So let's do source file index. Value is equal objects.require non-null. Entry.get value original but then we can just do value like that, and then return. Yeah, we don't need to do that though. We can just use map.copyof because that does the exact same thing, right? So that's fine. Now why is this complaining? Because it's already assigned to that value. Yeah, I mean it technically is. Wait, is it? I don't think it is, actually. No, I don't think it is. I think that's wrong. But this is fine. Okay, and then we can build our first method. So then we can make our private static map of string to a list. Yeah, basically this. We can take that out though, because that's not going to be correct. Then we want our map of string, comma, list of source file index. Will be the index is a new map. Okay. And then for each file, we can do a file.package name is equal null. We can just continue, and then compute if absent. We can do $sign there. Okay, and then just return map.copy of, right? Kind of, but we want to also make the lists immutable. So we're going to want some kind of like private static t map of string list of e, and this will just copy a list map like that. I think that's fine. But then we can just return copy list map index like that. Now all the other ones are going to be basically exactly the same, I believe. So yeah, we've got a symbol descriptor. This will be declared symbols though, but the rest is going to be fine there. And then qualified name. Yep, that's fine. These don't need to be collections. These can just be even iterable to make our lives a little bit simpler. Okay. And then the final one looks about correct. It's probably fine. Okay, let's create these classes because it's kind of bugging me that we don't have any of these classes. Despite having no clue what's going on, I like to watch these. I also have no clue what's going on, so I'm glad you don't either. That was half a joke, half not a joke. Half the time I do know what's going on, half the time I don't know what's going on. This can be null. There you go. We do want declared symbols, but we also want imports as well. Import descriptor imports. Okay, let's just do a little bit of validation in here as well. It reckons we should that makes sense, yeah. Okay. It does want us to create a method here. At nullable. We should also switch at some point to JSpecify annotations rather than JetBrains annotations, but it's just so much effort I can't bother to do it right now. Because you're not meant to use JetBrains annotations anymore, but kind of everything is, so... Oh, am I using the wrong nullable here? Okay, wait, I'm using the wrong nullable, I think. Yeah. This needs to be... that one. No. Don't want that. If name is null, return null. Yeah. And then we just want to trim it. If it's empty, then we return null. I mean, we might as well just make that a... Okay, so let's call it... No, we don't even need to do that. We can just do... name is equal name.trim. And then do name is empty. Then we do null. Or we do value. And then we can just do... package name is equal normalize that. Let's also make sure these aren't null, so we can do objects require non-null, objects.require non-null, and then we just need to get the declared public set of string declared qualified names. So for symbol descriptor in that. If symbol.qualified name is not null, we just add that and then return it. This can just be set.copy of, because Copilot always forgets that exists, I guess. So, you know, whatever. This can also just be called names. There's no reason to overcomplicate that. Then we can define the import. So imports are going to be pretty simple, right? It's just a name. This is not what is an alias? What? No, don't have an alias. That doesn't even make sense. We need to know, is it static, and also, kind of more importantly, is it wildcard? And then we can just do that. I don't think we care about if it's empty necessarily. Probably should be empty, but I wouldn't say it's necessary that it's empty. Okay, that's fine. Well, maybe we should. I don't know. Yeah, we might as well. Private static. String require name, string value, string name, value is equal that. If value is empty, then return name cannot be blank. And then just return value, and then that means we can just do, probably put that down here, doesn't really matter, but it's a bit cleaner if we do that, isn't it? Then just require name qualified name, so that's much simpler if we do it like that. And then next one is the symbol descriptor, so public record symbol descriptor. Yeah, that I can already tell that's not right. So we're going to want a symbol kind. We're going to want a string simple name, qualified name, owner qualified name. Because it's a symbol, it might have a signature. So string signature, like a method, for example, would have a signature. Even fields have signatures, kind of, because they have a return type. Then we have the path it came from. We have a boolean is static. And then we can have a boolean is top level as well. Okay, so kind. Not already assigned to that though. Is it? No, it's not. Normalize option name, normalize option name, normalize option name, and then normalize path. Okay, that's fine. Well, I mean, I'm just trying to think, do we want to simplify this at all? I'm going to say no. We'll just leave it as it is. Public Boolean has qualified name. Public Boolean is member. And we can also get these as optional. Why isn't it like that? Right, because it can't be called that because the field is called qualified name. And then we could do the same thing for... Okay, like that. Okay. And then that fixes like most of our errors, but we do need the builder, of course. So I guess let's do the builder now. Sure. Just come below everything and we'll do a public static final class builder. Do a private final map of path to a source file index. Files by path is equal to a new linked hash map. Yep. Then we want a private constructor. Yes. And then we just want a way to add a file. Yeah, but we don't need to complicate it that much. We can just do put file. And we can pass in a source file index, which is the file index. And then if we just do file index is equal require non-null. And then just do files by path dot put that, and then just return this. And then also let's add a way to remove a file like that, and then we just build it like that. That's basically it, right? We probably want a couple more methods in here though. So like we can get a file, but like we can't look anything up, or we can't like, I think that would be good to do is get the list of files in a package. So like a public list of source file index, get files by package. Yeah, effectively that, but we want to do some validation. So package name is equal normalize option name. If package name is null, return an empty list, else we just return that. And then we can do like a list of symbol descriptor, lookup simple name, normalize. Well, yeah, no, we can just require it. Well, no, because we don't want to require name throws. We don't want to throw. We just want to return an empty list. So no, we don't want to require name. We want to do normalize option name. If it's null, return an empty list. Qualified name will be identical. And then we want a way to like look up the members. We don't need all of that shenanigans though. We can just call it lookup members. That's fine. And then let's also have do that. Then let's have a public list of symbol descriptor, lookup member, which will have the qualified name and simple name. This is, I think, unnecessarily complex though. We can just do simple name is equal normalize. That's null, return that. That's null, return that. Yeah, we should have done these the other way around. And then we can just return lookup members, stream it, filter it to list. Simple name equals, yeah, that's correct, no? Because it needs to be final. Wait, it is final. Oh no, it's not final. I see. Right. Okay, well, we'll just have to do final. String member simple name. And just do that. And that'll work. That's fine. That's basically it for that class, I think. Right? We don't need to have that to do anymore because we've actually just done that. What are these? So that's saying it's already assigned to that. And we can annotate these as not null. Just to be explicit, really, more than anything else. So like kind, we can say is not null. There we go. Okay. Okay, I've also got codecs to write us some tests. So let's just have a look at those real quick. IDE. I don't know where it's put them. SST. Oh yeah, SST makes sense. Here we go. Okay. Looks okay. It says the test has failed, though. Oh, it reckons there's something wrong with our normalized path method. I think that's fine, no? Does that not look fine? Okay. It says it is fine, actually. It messed up right in the test. Of course it did. And then, yeah, so now that we've defined this, effectively what we need to do is actually build these indexes to pass in to here. So we need to obviously use the builder, right? Now, that's not going to be super easy. So it's not also going to be as easy as that even, because we can't just like index them. We also have to scan them and like figure out what they are. So we're going to have to use the source file index for that. So where do we even want to put this? I guess in here. We want some kind of like source file index extractor or something. Or maybe even we do this in the semantic analyzer. That's a good question. Because, I mean, really, we already have everything in the semantic analyzer, right? So there isn't much point, like, redoing the whole thing. It'd be better if... Oh, yeah. If it could basically just export it for us, right? So I think, no, I think we should create a class in here regardless. Like a Java project... semantic extractor. Is that fine? I think so. Make this a final class again. And then if we just do like a public source file index extract from a path and a char sequence source, then we can do semantic model is equal to Java semantic analyzer. So analyze declaration facts from the source and then return, and then we'll have a way to just extract it directly from the model. So we'll do extract path model, and then we'll have a public source file index extract path model. We'll take the root. Yeah, that's just a syntax tree like that, and then that's just root. And then we can do string package name will be extract package name. We can then take a list of import descriptor imports is equal to extract imports, and then we'll take a list of symbol descriptor symbols is equal to extract symbols, and pass in the path, the root, the model, and return a new source file index which takes path package name imports symbols. That needs to be imported, I think, which is why it's complaining. Yes. Okay. So first of all, we need to pass the package declaration. So let's do a root, and then we can do syntax node package declaration is equal root dot no, I think we need to take in the context. I don't remember how this works. So from the model we should have, I believe, maybe it's from the syntax tree. Like we can do diagnostics, which passes diagnostics. Somewhere we have the context, I thought. Syntax tree? No. I mean, we can kind of scan to children, but that's not really what we want. The scope obviously doesn't really help us. But I mean, this calls that, which calls perform analysis. Oh right, and then that has the analysis context, which is what? Right, because this is what basically has it all, and it's what allows us to grab. What the hell? So what allows us to grab everything. So let's do this, and then I guess let's just go through the root children, and then let's do kind of ID and say that this equals I think it's just Java package declaration, and then just return next name is the last identifier. Is that right? Well, no, we want the whole thing, right? So can we just do package declaration dot children? Because we want to get the qualified name from the package declaration, right? So I want to do syntax node qualified name is equal package declaration is equal let's just set that to null, and then just do for each children if it's a qualified name. I think it'd be beneficial to have a method that does this. Let's create some methods, I think. So let's create a private @nullable syntax node, which will be a direct child. So it's basically going to be a copy of what we have in the inspections. And then that takes in the kind. And then basically just do this. So that allows us to get that, which is what we want. So then what we can do is There's not much point doing it like that, I don't think. We can just return null here. So if question, can we access Java syntax kinds? Syntax kinds. Is that not what I called it? That is what I called it, no? Import Java. That is what I called it. Oh, it's a final class, I see. Okay, fine. Let's say if it does not equal child.kind.id. Continue. Then let's get the syntax node. Qualified name is the direct child. That would just be Java qualified name. If qualified name is null, return null. So you can only have one package declaration, right? So then string text is going to be the text. We'll come back to that in a second. And then just return text is null, or text is blank, then null or text. And then okay, let's make this method. So let's have a private string pattern qualified name syntax node. Then let's do a string builder like that. Yeah, builder is equal to a new string builder. And then append qualified name to the other way around. Node builder. Is there any reason you can't change visibility to public? No, to be honest, there isn't. And I will at some point, but all the inspections I've wrote so far haven't, so I would also need to change all the inspections to use those. It wouldn't be too much work, but I just haven't done it. And it's kind of out of scope of this specific branch, so I can't do it on this branch. So unless I want to switch back to the other branch and then do it, it's not really worth doing as of right now anyways, so we'll make that nullable. There you go. Do that, not like that though. I don't know what all of that was because that's not correct. If node is instance of a syntax token, then we want to do builder.append token.text and return. And then we want to do node.children.for child, and we just want to recursively call that method on the child like that, which allows us to flatten it, which means that here we can just call flatten qualified name, passing in that qualified name node. So that it then therefore extracts the package name. So next is extract import. So we'll do a private imports. Not going to be that though. So first of all, I mean, let's just define our import. So we'll just do a new array list like that. And then I guess if we just loop over it. I mean, this one shouldn't be too hard to do. So for child, and we just want to check if that's an import or not. So pretty much the exact same thing. We'll just take that. This I think is just import declaration. So if it's not an import, then we do syntax node import target is the direct child. I'm not sure actually. How do imports work? Yeah, I didn't think it went to a qualified name. It goes to an import target first. And then it goes to a qualified name afterwards. If import target is null, then we continue. Then we do string qualified name. We flatten that on the import targets. It's null or blank, we continue. Then we can do boolean is static. And we can do has token child Java token type dot static. And we can do boolean is wildcard is equal. We can probably just do that, right? Is that not a thing? Isn't there like a star? Yeah, there you go, star. And then do imports.add a new import descriptor. Qualified name is static is wildcard. And then just return list.copy of imports. Boom, let's create our has token method. So private boolean has token. And then we want to do string token kind ID. Is that a thing? That's not a thing, right? No, we have to convert it. Java. That's a thing in here though, isn't it? Yeah. Okay, I am actually gonna have to make this public then, funnily enough. Because I need this method right here. Java syntax kinds dot token kind token type dot ID. And then for child and children, I mean, yeah, basically that, but like only if. So yeah, it needs to be a syntax token. But no, we don't do that because we need to get the children of said token, I believe. Well, yeah, that's fine. So if that and that, or we need to go through the children. So, or we need to go and say, let's make a method because otherwise it's gonna get weird. Because we need to get the children of the child. So like, unless we call it child's child, which is a terrible variable name, let's just make a method. Private boolean contains token. We're gonna have a syntax node. Let's do contains token kind. Let's call this has token kind. And rename these to has token kind. And then this will be the syntax node, and then we'll have string token kind ID. And then we want to do our if statement. So if node is instance of a syntax token, then return that basically that's equal. So we get rid of these. And then we can do node.children.for, so for child. And then just call it recursively, I guess. So if that's true, then return true, else return false. And then that way that in here, we can just get rid of that loop even, can't we? Yes. Indeed we can, actually. Oh, so we could have done it in here then. Alright. Oh well. We've done it there now. It doesn't really matter. Okay, so next one then is extract symbols. So let's do a list of symbol descriptor. This one's going to be more complicated, I think. But I mean, we'll see. So do we just want to do a list at the start? I suppose so. I don't think we want to do anything too special here. At least in terms of like the overview of things. So then let's, I guess, just like call a method. So collect symbols. Pass those in, sure, I guess. And then let's do a private void collect symbols. And we're taking a path, and we will take in a... Oh, I literally have it right here. What am I doing? Yes, kind of. We don't want all of that though, right? Can we get declared symbol? Yes. So we want to get the node and then filter to say that the symbol well, we want to know that it's one of the symbols that we want to index, right? Is indexable kind? I don't know. That's not a great method, is it? Indexed in. Yeah. Yeah. I suppose. Or indexable. Indexable just doesn't flow. Like, it's just not. Doesn't really work. I feel like. We can just pass in directly the kind. And then if present, let's do symbol and do symbols dot add, and we want to convert that to a descriptor. Path node symbol, and then we want to go through the children and basically recursively call that, and then we can just implement this method. So private boolean is index kind, and here we want to go back to Java syntax kind, I think. Do we? No, because it's not a syntax kind, it's a symbol kind, right? Yeah. So a symbol kind, we go into here, is just these. So these shouldn't be strings. This is just a symbol kind like that. And then we can do like, yeah, these basically. So class, interface, enum, annotation, record, and then we have method, field, constructors, and then default we just false, because we don't care about anything else, right? And then kind of the important part is that we actually need to convert this into a descriptor, and it's actually descriptor, not descriptor. And then we'll do private symbol descriptor to descriptor. We'll take in these. So let's just do syntax node. Let's get the container first of all. So the declaration container. Like that. And then let's get the qualified name. Will be equal to symbol. Wait, we're not passing the symbol in? We do need to pass the symbol in, otherwise that's not particularly useful. Oh, we are passing in the symbol in. Wait, why are we passing in the symbol kind? That's not right. That should just be the symbol. So then we can just do symbol.qualified name. Right? If we import that, of course. Yes, symbol.qualified name or else null. And then we can just return a new symbol descriptor, which will take in the symbol kind, the simple name, qualified name. Then we have the owner qualified name. So we're gonna have to get the owner qualified name of the symbol and the qualified name. Then we're gonna have to extract the signature from the container and symbol.kind. Then we're gonna have to pass in the path, nice and easy one. Then we're gonna have, right, so what's the next one? Is static. Okay, is static declaration container. And then we need to know if it's top level. So is top level type declaration, or let's just do is the top level type container, and then we can also pass in the symbol kind as well. Okay, let's go one by one. So first of all is declaration container. This one should be pretty simple. So we can just do a private syntax node declaration container syntax node if variable declarator that equals that, then we can just do node.parent. Why is that erroring? That's an optional. Okay, we just need to then say or else node then, and else we just return the node. Owner qualified name. Okay, so we'll do private. Sure, let's get rid of that because I'm not sure Codex is going to be, or Copilot I should say, is going to be correct. If qualified name is null, or it's blank, first of all, then we'll just return null because at that point we don't care. And then we want to know what it is. So if kind is a field, or the kind is a method, or the kind is a constructor. Don't forget about the constructor. Then effectively it's going to be like you know, it's going to be like a.b.c hash xyz, right? So really we want to get that a.b.c, so we can do int hash will get us the qualified name dot index of the hash, and then if hash is greater than 0, then we can just substring it and then return qualified name. Well, no, here we just want to return null, right? In that case it hasn't gone to plan, so we just abandon, I suppose. Then we have extract signature. I think we'll come back to that one because that one's going to be the complicated one. So next then is static declaration. So private boolean is static declaration, and we already have a method for that, so that's nice and easy. Then we have is top level. So let's just say if not is type kind, and then we'll make this in a second, and that will just do basically what Copilot just tried to do, but like in a method that's easy to read. Then I guess we just want to do a for loop. Or actually current is equal node.parent or else null. And then let's just do a while loop actually. And then we can say if is type declaration node current, return false, else current is just the parent, right? And finally here we return true. And then type kind is just going to be a simple switch statement, so private yeah, classes, interfaces, enums, annotations, records, yes. And then is type declaration, I mean this is kind of going to be similar, so yeah, I mean it's basically just going to be this. So class declaration, interface declaration, enum declaration, annotation declaration, record declaration. That's fine. So is that all of our methods? Yeah. So we just have to do extract signature now. Goodness gracious. Okay. So let's do... This is going to be the complex one. So we'll do string. Yeah, but let's get rid of this and we'll write it ourselves. Okay. So for now, let's skip methods and constructors. We'll do everything else first, I think. So if kind... Or, no. Wait. I'm just trying to think. Am I right in terms of everything else? No, I guess only methods have signatures, don't they? So if it's not a method, if it's not a symbol kind.method, and it's not a constructor, then we return null, right? Else we want to get the parameters. So syntax node parameter list is equal to a direct child of node, and we want to get Java parameter list. Is that right? Yes, that is right. Okay, lovely. So if that's null, then we can just return some empty brackets, because that means just there aren't any parameters. Then we just want to get basically each type as a string. So then let's just do parameter list dot children dot for. Let's get the string kind. So if it's not a parameter and it's not a receiver parameter, I actually forgot about receiver parameters. I would not have added those if Copilot didn't mention those. So very good job it did. So then we need to get the type. Now that's on Java type. I'm not sure that's correct though. Yeah, it's Java type reference. It was close, but not quite. Just call this type ref as well. So if that type ref is not equal null, then let's get the string text is equal flatten qualified name. And if it's not null and it's not blank, then we can add it like that. And then here we can just return that, which gets us like a very basic signature, right? I mean, I am just thinking though. I mean, for the most part, we're not gonna need like generics or anything, but I'm just thinking if there's a case where we might want those in the future or not. I think for now it's fine. Yeah, I think it's fine. Maybe we'll come back to it. Let's put to do in here. Do handle or improve signature extraction to handle generics var args. To do improve signature extraction to include type, to include return type for methods like that. and then we'll come back and we'll do those at some other time. For now, I don't think we're gonna need them for anything, so we can just leave them out. Because it's important to remember this is only for indexing. But like later down the line, when we want to add smarter indexing and like smarter things, like for example, if you're typing like int I is equal you know, some class dot some method, you might want your methods that return integers to be at the top of the suggestions. Something like that is when we would want to add return types here, but for now I think it's fine and there's no need to like go crazy with it. So that's fine, I think. Honestly guys, I think I'm gonna like end the stream here. We're not gonna get anything working today, even if I continue. Because to move forward, well, I mean, even if we like get it quote unquote working, having something to be able to test it on would require a lot more integration beyond what we currently have. So I think we're basically at our limits here. Because to get it working, really, we have to be able to scan the files, and that's the part that's actually like the complex part. So yeah, okay. But we've made pretty good progress here. I'm going to quickly commit this to GitHub. And do that. Okay, commit. Alright, and I'm going to go ahead and end the stream here. I hope you all enjoyed. As I say, I will not be live next Saturday, but I should be live on Sunday. Yeah, I hope you all enjoyed. If you're not in the Discord already, feel free to join the Discord, linked in the description. And I will see you all next week. Goodbye.